Hello again. Last week, somebody, not going to name any names, might have said something reasonably nice about the video, and that was all the excuse I needed to make another one. So hopefully you'll find this useful. We're going to be talking about polymerization, which links really nicely with what we did last lesson on alkenes, because alkenes can be used to make polymers. And well done to those of you that picked up on the silly little wordplay that I had at the end of the presentation. So, polymers. What we're going to cover today is recall the basic principles of addition polymerization, refer to the functional group of a monomer, and the repeating units of a polymer. Now, that's pretty vague. So, a bit more in depth, we're going to understand that polymers can be made from alkenes, and we're going to talk about addition polymerization. There is another type of polymerization coming up later on in the course. Not to worry about it now. We'll cover that later on. And you're going to demonstrate how to draw repeat units and identify monomers from sections of a polymer. Now, to start off with, in 4 steps, without words, bit of creativity, you artsy types, how can we get from crude oil to a plastic bag? Can you draw out a couple of little cartoons in the back of your book, scrap of paper on a whiteboard? How would we get from crude oil to a plastic bag? Excellent. Now, if you've paused this video and had a go at it, great. That's what I'd encourage you to do as we go through this lesson, this presentation. Give yourself the opportunity to answer the questions. Don't just try and say them in your head and then skip forward to the answers and be like, oh yeah, I would have said something similar to that. Be really harsh. Give yourself that opportunity to get it wrong or get it right. If you write it down and you get it wrong, that's fine. You can learn from that mistake, but give yourself that chance. And as if by magic, we've got some questions to go through. Don't worry, I'm not going to read through all of the questions one by one, but I'm going to put them up on the screen. You can then have a look at the questions, pause the video, and whilst you've paused the video, have a go at answering them. Write them down. And then unpause the video and we'll go through the answers. Cool, now that you've unpaused the video, we've got some answers. What type of reaction is it? It's an addition reaction. You could also say that it's bromination because we're adding bromine into the molecule, or you could say it's halogenation. The generic all-encompassing term though is an addition reaction, and that means that you could have said that if it was chlorine being added, or if it was bromine or iodine, a bit more generic. A molecule is being added to ethene. That's why we refer to it as an addition reaction, because we're adding something to the ethene and making a new molecule. Ethene has a double bond which can break, freeing up 1 electron from each carbon for the formation of a new bond. If you're happy with that as an explanation and you can visualize that in your head, great, well done. If you can't, this little video is for you. This little vignette will look at visualizing the addition of bromine to ethene, or any halogen to any alkene. Now, if you're happy with alkene plus halogen makes a dihaloalkane, brilliant, and you know how to apply that, that's excellent. If you want to try and visualize it, this is what we're going to go through in the next minute and a half. In our alkene, we've got carbon-carbon double bonds. We've got 2 shared pairs of electrons. One of those shared pairs of electrons is going to break. The bond is going to break, which results in 1 carbon having an unpaired electron and a second carbon having an unpaired electron. And that's what's going to allow it to make new bonds with the bromine. So the first carbon can make a shared pair of electrons. So the carbon has now got 1, 2, 3, 4, 5, 6, 7, 8 electrons. That brown circle from the bromine, we've now got 1, 2, 3, 4, 5, 6, 7 electrons on the bromine, and it's sharing the 8th electron with the carbon. It's made a covalent bond. Over here, Carbon's unpaired electron can pair up with an electron from bromine. So we've got 1, 2, 3, 4, 5, 6, 7, and bromine's 8th electron is the one that it's sharing with the carbon. And that's it. Excellent. And now that we've seen that video, hopefully that makes a little bit more sense. We can use hydrogen and a nickel catalyst to turn an alkene into an alkane, another addition reaction where we're adding hydrogen across the double bond, making it go from unsaturated to a saturated molecule. If you're not confident with those terms, saturated, unsaturated, go back a couple of lessons and have a look at what we looked at when we were talking about alkanes and alkenes. Dibromoethane. Cracking is a way of turning long chains into short chain alkanes and alkenes. So for example, we could have nonane becomes ethene and heptane, or C9H20 produces CTH4 and C7H6. Again, if you're not confident with that, go back to what we were talking about last lesson and look at alkanes, alkenes, and specifically alkenes and cracking. Now here, we've got two different general formulas. CnH2n for the alkene, and for alkane, CnH2n plus 2. Or in other words, C7, H, 7 times 2 is 14, plus 2 is 16. CnH2n, 2 times 2 equals 4. So we've got two general formulas. Again, if you're not confident with general formulas, go back to the first lesson where we start talking about general formulas and alkanes. Looking at addition polymerization. We covered this in year 9. However, we're going to go through it again just to make sure that you're comfortable with it. When we talk about addition polymerization, we're focusing in on the functional group of the alkene, which makes this possible. The functional group is the part of the compound that enables it to react in a certain way. And for the alkenes, the functional group is the carbon-carbon double bond. Because it's got a carbon-carbon double bond, it means that the carbon can break one of those bonds, generating an unpaired electron with one carbon and an unpaired electron with the other carbon. Because you've got those unpaired electrons, those carbons then can bond and make new bonds with neighboring molecules. We'd refer to each of the alkenes as the monomers. Those monomers are the things that can be added together to make a really long chain. We'd only use one type of monomer, and that is our unsaturated alkene. Again, if you're not comfortable with the words unsaturated and saturated, go back to previous lessons and have a quick look at that. No molecule is eliminated during this polymerization. We are just adding them together. So adding together lots and lots of monomers, lots and lots of small molecules together to make a massive long chain. Just like you would do, like you're adding paper clips together to make a long chain of paper clips. Each individual paper clip is the monomer. The long chain is then the polymer. Another way of looking at this is the carbons. Carbon double bonded to carbon, carbon double bonded to carbon, carbon double bonded to carbon. We've got 3 monomers, 1 ethene, 2 ethene, 3 ethene. 3 monomers that we can add together. And what happens when we add together is one of the carbon-carbon bonds, one of the bonds within the double bond breaks, allowing or generating a spare electron or unpaired electron with this carbon and an unpaired electron with that carbon. The same happens here. One of the bonds in the double bond breaks. Carbon has an unpaired electron. This carbon has an unpaired electron. The unpaired electron on this carbon and the unpaired electron on this carbon are able to join together to make a covalent bond. So we're then bonding this carbon and this carbon together by a shared pair of electrons. And so on, and so on, and so on, until we get a long repeating unit. So repeat unit, repeat unit, repeat unit. We get it repeated again and again and again. And it creates this really long chain where we've added lots and lots of small molecules together. One way of looking at that, rather than just writing it out again and again and again, which, let's be honest, could become slightly tedious, is to simplify it, where we identify what the monomer is. And said that has been bonded to neighboring molecules, and it's been done again and again and again. And rather than writing that out, we say that there is n amounts of the monomers being put in, and those monomers are then repeated n number of times again and again, bonded to each other. That n just represents a number. It could be a massive number, talking millions and millions and millions and billions of monomers joined together in a long chain. What we've got here is the repeat unit. So going back a slide, the repeat unit, this section. So we've got carbon, carbon, carbon. We've got the monomer has been repeated again and again and again. Couple of key points. I want you to make sure that when you're drawing this in the future, and especially in the questions that are coming up, make sure that the bond from the carbon extends out of the square brackets on both sides. That's indicating that that carbon is bonded again. It's bonded again and again, and you've got additional things bonded to it that repeats again and again and again. Repeat units. Very quickly, looking at that line of triangles and squares, what has been repeated? What is being repeated? What's the pattern along that chain? Hopefully you went triangle, square. If you went square, triangle, you're absolutely right. You can have it either way. What about this? What's the repeating pattern along this chain? Absolutely, triangle, square, circle, or circle, triangle, square, or square, circle, triangle. Again, as long as you've identified what the repeating unit is, that's absolutely fine. And what about along this chain here? Excellent. Well done. So repeating units. Very similar, in fact, the same as the first example that we looked at. What about the one down here? What about this? What do you think the repeat unit is? Absolutely. Well done. Now, I'd like you to have a bit of a practice. I would like you to take the individual monomers that we've got here, and I'd like you to write down what you think the name of that polymer is. So, for example, ethene has become polyethene. Poly meaning the monomer of the polymer of the monomer ethene. Poly, long chain of repeating ethene molecules. So what do you think the polymer name for the polymer formed from chloroethene would be? Then I'd like you to have a go at drawing the structure, what you think it will look like with the square brackets and the N, and draw the repeat unit. We'll do the same for propene, and then just to mix things up and make it a little bit more difficult, we've got poly, tetra, fluoroethene. Now the challenge here for you guys is to convert this polymer into a monomer, and can you name it? I'm going to give you opportunity here to pause the video, have a go at doing the answers, and then we'll go through the answers on the next slide. Excellent. Right, I want you to mark yourself. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. How did you do out of 9? Mark yourself. If you got 9 out of 9, that's really good going. Well done. You should give yourself a round of applause. If you've made mistakes, don't worry about it. what I want you to do is make sure you correct them. Don't just leave the mistakes in your book on the page. I want you to make sure that you correct them, because then hopefully you'll be learning from those mistakes and you'll identify where you went wrong, and then you're not going to make those mistakes again. And that's us done for the lesson. Well done.